In this lesson, we're going to examine a new tool, one that's useful when we don't have a right angle triangle. Pythagoras, SOHCAHTOA, great tools, but they only work with right angle triangles. And of course, things in the real world are often not just right angle triangles. So what we're going to look at today is something called the sine law, and we use it when we have a non-right triangle. It's a more powerful tool. Okay? With these non-right triangles, what we're going to do is go back to the idea of proportional reasoning and examine the relationship between a side and the angle on the opposite to it. Okay, so obviously triangles have three sides, they have three angles. The ones across from each other have a relationship. Now, before I show you the formula, the sine law, some important information down here at the bottom. When you label triangles, capital letters are always the angles. So if this is big A, the small letter across from it is always the side. So big A is across from small a. Big B is across from small b. Big C is across from small c. Big ones are angles, small ones are sides. Here's our sine law. You're going to want to write this down somewhere. The sine of angle A is proportional to side A. The sine of angle B is proportional to side B, and C with C, of course. Now, we've seen things that have three fractions. We rarely use all three at one time. We're going to pick two of the fractions and solve them. We'll do some examples, and you'll see how this works in just a second here. Okay. So, let's take a look. There's really only two problems that we can do, a missing side or a missing angle. We'll start with the easy one. Solve for the unknown value. Unknown value is little z. That's what I want to find. But I need to start thinking to myself, well, what tool do I use? Can I use Pythagoras? No, it's not right angled. Can I use SOHCAHTOA? No, it's not right angled. So I need something else. To use the sine law, you have to have a pair of things that go together, an angle and across from it, and a side. And you have to know both numbers. So you have to be able to write down the sine of an angle that matches with the side. If you can't write down those two pieces of information, you can't use the sine law. And then you have to write down the pair that you want. Well, I want side Z. It's going to go on the bottom because I put my sides on the bottom. On the top, I need the angle across from it, which is angle Z, which is this angle, which we don't know. Well, not directly. We actually know angle Z because we know things about triangles. We know that triangles have three angles, 50, 70, and whatever this one is, and they have to add up to 180. So I'm pretty sure I can take 180, get rid of the 50 and the 70, and I'm left with, angle Z has to be sine 60. Okay, so make sure that the sine goes with the angle. Sine 60 is my angle, Z's across from it. Now we only have two kinds of math we can do. We can cross multiply or we can do inverses. Well, here we're looking for a side, so we cross multiply. We're going to do Z times sine 70. That makes Z sine 70 equals. We're going to do 17 times sine 60. That's 17 sine 60. We didn't get Z by itself, but we can fix that by dividing out the sine 70. And whatever I do to one side, I do to the other. Those ones cancel, and I'm left with Z, which is, take out our handy dandy calculators here, I got 15.7. And there we go. We found a missing side. Sine law. Okay, let's try the other problem, the missing angle. Again, we ask ourselves some questions in our head. Could I use SOHCAHTOA? Could I use Pythagoras? Not right angled? No. Guess I need a new tool. So, do I have a pair of things that I know that are across from each other? Well, the 32, which is an angle, is across from a 43. I've got a pair. I can write down sine of 32 goes with 43. I need a pair of things to be able to start this off. And then I need the other pair. The sine of the angle, which I don't know, called theta, goes with the 37. And I ask myself two questions. Inverse or cross multiply? Well, I want an angle, so I need an inverse. But to be able to take an inverse, I want the word sine or cos or tan, the function, by itself. And right now it says divide by 37 underneath it. So we're going to do this is the tricky part here, a partial cross multiply. To get rid of the 37, I'm going to bring it up and multiply. So it's going to be 37 times the sine of 32, all divided by 43, leaving just sine theta by itself on the right-hand side. So rather than doing both cross multiply, rather than bringing this up here, I don't want to do that because then I have something attached to sine again. I want to get sine by itself. I did a partial cross multiply. Okay, so just the 37 came up. Well, good news, we got sine theta. I want to know what theta is, though, which means I need the inverse of this big mess of stuff. That big long decimal, whatever it happens to be. I don't know what it is. Let the calculator do the work for me. But type it in the way it looks. And I got 27.1 degrees. Now try them yourself. If you can't get your calculator to work for whatever reason, bring it in. We'll talk about it and we'll figure it out. That's it. That's the sine law. Only two questions we can do, a missing side, a missing angle. The math in this unit isn't super challenging once you get the hang of it. We're just getting the hang of it today, so yes, it's hard right now. But down the road, the math won't be the hard part. It's always going to be those pictures. So let's try one of those pictures. Pause it, read it, try it. See if you can make the picture. If you make the picture, try the math. If you got this one figured out, you kind of got the sine law figured out. We have a wall that's 1.4 meters tall that started to lean and now makes an angle of 80 degrees with the ground. So in my diagram, I see my wall. Here it's leaning. It makes an 80 with the ground. That's going to be 80. Okay, a 2-meter board is jammed between the top of the wall and the ground. So this line right here is 2 meters. And it props the wall up, assuming the ground is level. What angle does the board make with the ground? That would be that angle right there. Now, get rid of my clip art and just bring this guy over here. I don't want my picture. Give me my picture. Let's get rid of the mouse here, guys. Sorry, 1 second. Mouse. There's my picture. Okay, we want to know what angle does it make with the ground. Boy, I missed a number here. It's 1.4 meters tall. Okay, find x. Well, can I use SOHCAHTOA? No, it's not right angled. But I know a pair of things that go together. I know that the sine of 80, that angle, is across from side 2. They're across from each other. I know that the sine of x is across from the 1.4. Hey, it's like the question we just did again. I want to get the x by itself, which is an angle, which means I need an inverse. But I can't do it directly. I have to get rid of that 1.4 first. So it's going to come up. It's going to cross multiply. And then divide by 2. I want to know what x is. So I'm going to take the inverse of this mess of stuff. And I'm going to let my calculator do my work for me because my calculator is smarter, remembers the numbers better. It gave me 43.6. See if you guys agree with that. All right, part B. How far is the base of the board from the base of the wall? In other words, how big is the bottom here? Well, it's still the sine law because I still know that the sine of 80 goes with 2. That hasn't changed, right? These two things are still across from each other. And if I want to find y, which is the side, I need the angle across from it. I need to know this angle. Well, I can find that angle if I stop and think about this one being 43.6, because now I have 2 of the 3 angles in a triangle. And if you know 2, you always know 3. The last one is 56.4 to make it add up to 180. Okay, question is inverse cross multiply. Well, it's a side, so we're cross multiplying. So we're going to do y times the sine of 80 equals 2 times the sine of 56.4, just cross multiplied. I didn't get y by itself, but I can do that real quick by dividing by sine 80. Whatever I do to one side, I do to the other. And y is, I got 1.69 meters. See if you agree with me. That's it. There's your sine law. Okay? If you master that, if you're able to do that by yourself, you've got this figured out, because that's basically the two questions. Missing side, missing angle. There is one more question I want to try, though, because we want to see how else we can use this and what else we can do with this and push ourselves a little bit. So we'll try the last one. Pause it, read it, try it. Okay, a bridge across the valley is 150 meters in length. So the bridge is 150. The valley walls make angles of 60 and 54 with the bridge that spans it. So there's a wall on this side, there's a wall on this side, we got a 54 on one, we got a 60 on the other. Doesn't matter which one's which, your choice. And we want to know how deep the valley is. Well, the depth of the valley goes right down the middle. There's my depth. We'll call that, I don't know, call it H for height maybe, because that's what that is, the height of the valley. There's our picture. I'll point out to you guys, what kind of picture is that? Well, those are right angle triangles, because it went straight down the middle, already straight down, and maybe not in the middle, but it went straight down, so they have to be right angle triangles. Now the question is, can I use SOHCAHTOA? Well, I have right triangles, so I should be able to, right? SOHCAHTOA needs an opposite, adjacent, and hypotenuse. So I think about the angle 54, for instance. Well, the opposite of the 54 is definitely this one right here. That's my height, which I don't know. The hypotenuse of that triangle is this one, which I also don't know. And the adjacent is this one, which, well, it's not 150, because 150 goes all the way across. And it's also not 75, which is a common mistake. People think you could divide it in half. But you can't say it's 75 on this side and 75 on this side, because this triangle that we have here is not isosceles. Those are not the same angles. So it can't break it perfectly down the middle. So I don't actually know the adjacent either. So I'm going to erase all this stuff because that just causes confusion and go back to what I do know. All I know is that. That's all I know. But I want the height. How can I find the height? Well, if I were to get one of those extra sides, then I could use SOHCAHTOA. So how about we try and get ourselves this side? Can I do that? Well, sure I can. I can do that by thinking this is a big triangle. That I know two of the three angles, which means I actually know the third angle, the one that's missing, 60 and 54 together. What's left over? Well, this angle has to be 66, which is across from the 150. That's a pair of things that go together. And if I want to find side x, it's across from the 60. Well, that's a cross-multiplying question again. Yay for us, we know how to do this. Okay, x times sine 66, that's just x sine 66. 150 times the sine of 60, we can do that too. Get x by itself, so we're going to divide by sine 66. And they cancel, we get x by itself. Take out our handy dandy calculator. 150 sine 60 divided by sine 66 is, I got 142.197, so 2. And there we go, we got ourselves this side. That's really helpful for us because now I can stop and think of this as a right angle triangle that has a height I want to know, an angle of 54, a hypotenuse of 142.2, and that is just a sine question. And not a sine law, but a simple sine of 54 equals opposite over hypotenuse, which is a simple, just cross multiply kind of question, which I can dip in my calculator. 142.2 times the sine of 54 is, I got 115. It's actually 115.04. And that's how deep the valley is. Okay. So I couldn't find the answer directly because I didn't have the information to talk about SOHCAHTOA. I needed an extra side, which is why I need the sine law. Now I do want to point out, you didn't have to find x. Maybe some of you found y first. But you do need one of the two hypotenuses because we can't use the 150 and break it in half. We don't know how big that is, but we can figure out how big the hypotenuses are. Okay, that's our sine law. Here's our little practice questions for today. Give them a try, see what you can do. come into me, see some with questions if you have questions. There is really only one more rule we have to learn. It's called the cosine law. It's tomorrow's lesson. And then we're just going to practice. Whole lots of practice. Get really, really good at this. In particular, drawing those pictures, because pictures are hard.